Good morning, Math AH. We are going to be doing lesson 5.2b, and we're talking about graphs. And the fancy name for a graph is a coordinate plane. So a coordinate plane, fancy name for graph, is formed by the intersection of two number lines. Okay. A blank gives the coordinates, which is the location of a point. So the fancy way that we label point is called ordered pairs, and it's ordered alphabetically. Ordered pair. Coordinate plane and ordered pair gives the location of a point. The first number inside the parentheses is the x-coordinate. Get some math vocabulary in you. Coordinate. And the second number is the y-coordinate. For example, 2, 3, 2 is the x-coordinate and 3 is the y-coordinate. The x tells you how many units to move horizontally. It's telling you left or right. If it's positive, we're going to the right. If it's negative, we are going to the left. And the y-coordinate tells us how to move vertically, up and down. Positive, you go up, and negative, you go down. Okay, the x-axis is known as the independent axis or the horizontal axis. So horizontal axis. The independent variables graphed here. In science, you call it the cause and the effect. This is the cause. In math, we call it the independent and the dependent. The independent variable is graphed here, and the y-axis is known as the vertical axis. And the dependent variable is graphed here. Maybe we should change these to red. That might be better, huh? So you can follow along a little easier with the words that we put in. Our little vocabulary lesson here. Okay, the intersection of the y-axis and the x-axis. So where they collide, that is the origin at point 0, 0. Okay, and the word linear describes a straight line. So you don't have to say straight line. All lines are straight. If they're not straight, they're not lines. Okay? And the x and y axis divided into 4 quadrants. Okay, so this is, we go counterclockwise in mathematics. 1, 2, 3, 4. It makes us see like coordinate. Quadrant 1, 2, 3, 4. Okay? So if you are not in the quadrant, you're on an axis. You're either on the axes, you're on the origin, or you're in a quadrant. All right, so we're looking at where these points are. So coordinate A, when I look up, I have to go 1, 2, 3, and 2 up. So I know that the location of this point, is it going to give me a text box here? There we go. Is at 3 to the right and 2 up. So the x-coordinate is the 3, and the y-coordinate is a 2. And we write the point as 3, 2. Okay, so B. I count 1, 2 to the left, and 1, 2, 3 up. So the x-coordinate here is -2 because we went to the left. And the y-coordinate is +3 because we went up. So that is located at -2, 3. Wow, it really wants me to start my free tile. I don't want it. Okay, so in words, how do you plot 0.24? I would go 2 to the right and 4 up. From the origin, move 2 to the right and 4 up. Okay, and then we have to graph our points. Okay, so try. You can pause the video and then you can check your answers. All right, T at 1, -2. So I go 1 and 2 down, 1, -2. There's T. Okay, U, -3, -2. So I have to go left, 1, 2, 3, and down 2. V, -3, +2. To the left, 3, and up 2. W, right 1, up 2. Right 1, up 2. There's my W. Okay, so some graphing words. Independent, horizontal, dependent, vertical. The following tables show the relationship between cherries and pounds and cost. Is it proportional? How do you know? So I need to see if there is a value that I can multiply every time to get from one variable to the other. So 1 times 150 is 150. 2 times 150 is 3. 3 times 150 is 450. 4 times 150 is 6. 5 times 150 is 7.5. So then, yes, it is proportional. Yes. It is proportional. Because the amount times $1.50 always gets us our cost. We can also say because they always reduce 7.5 divided by 5, 6 divided by 4, 4.5 divided by 3, 3 divided by 2, and 1.5 divided by 1 all gets me to 1.5. Is the weight dependent on the cost, or is the cost dependent on the weight? So I have to think about when I go to the grocery store. Do I give the cashier money and then go get the cherries, or do I bring the cherries to the cashier and they tell me how much I owe? Usually you bring the cherries to the cashier. So the cost is dependent on the amount. Okay, so we're going to go from a table to a graph. We have to put our values on. Okay, so our first value was at 1, is it pound? Yeah, 1 pound is $1.50. Okay, so 1 pound, $1.50. Got it? And then 2 pounds is $3. And 3 pounds is $4.50. And $4 is $6. 4 pounds is $6. And 5 pounds is 7.5. Then I decide, am I able to buy half a pound of something? Sure, I can go to the store and buy half a pound. Am I able to pay part of $1? Yeah, I could pay like 25 cents or something like that. So then I'm going to connect it with a line, which is not the easiest thing to do on my program here, but you probably have an easier time. So I can see that these are all lining up. If I drew it nice and correct, these are all lining up. Ooh, I need a better color than that. We'll go purple. I think I need to go back and change my color first. Okay, there we go. These are all lining up. Okay, when it's proportional, we're going to see a line through the origin. How much would 0 pounds of cherries cost? Well, I'm not going to get charged for cherries if I don't have any cherries. So this is $0. $0. That's important because proportionals have to go through 0, 0, even though mine doesn't look perfect there. Could 0, 0 be put on the graph? Yes. Examine your graph. What conclusions can you make? It is a line that goes through the origin. When we have a line that goes through the origin, we are looking at a proportional relationship. Okay, let's do another one. So here, 1 times 2 is 2, and 1.5 times 2 is 3, and 1.75 times 4 times 2 is not 4. So I'm thinking that there might be something funny here because there is nothing I can multiply the price by to get to the number of MP3s. And some of you are like, what's an MP3? You had like records, then 8-track, then cassette tapes, then CDs, and then there was MP3s before you guys got your download and your streaming, all that. So taking us back a little bit, not too bad, but taking us back a little bit. Okay, so I am going to plot these here, and my MP3s are on the bottom because I usually order something before I pay for it. MP3s. Always label your graphs, and this is my cost in dollars. So this is dollars. Okay, I'm going to plot my points. So at 2, I'm paying $1. So I have to think this is 0.8, and it's going by 1, 2, 3, 4. So that's 0.9, 1.1. So right there, $1. And 3 is at 150. And 4 is at 175. And 5 is at 190. And 6 is at $2. And 10 is at $5. Okay. And if I try to make a line through this, if I tried to put a line in here, there's no way that I'd be able to insert a line. It wouldn't work. So I can't get a line to go through there. Okay, so are the number of MP3 proportion related? No. You can say lots of different reasons. So no, if I was looking at the table, so no, it is not proportional. Okay, I know that 2 over $1 is not equal to 4 over $1.75. So I can't, there's nothing I can multiply. Okay, or if I'm looking at the graph, it does not form a straight line. Okay, so my independent was at my MP3s, my dependent was my cost. These are things I probably should have answered before I graphed. What we notice about the graph, it does not form a line. So when something doesn't form a line through the origin, then it is not proportional. So this doesn't even form a line. Forget about through the origin. All right, let's look at the next one. The following table shows pounds of meats on a sandwich and calories in the sandwich. All right, well, 1 times 650 is 650, but 2 times 650 is not 830, so I know it's not proportional. I lost my page. Come back. Okay, so 650 calories over 1 pound is not equal to 830 calories over 2 pounds. All right, so here we usually get the meat to get the calories. So our meat is our independent. Meat pounds. And our dependent is our calories. Okay, so then I'm going to graph. I have to label my graph. So down here is pounds of meat pounds, and over here is calories. Okay, so half of a pound gets me 560. 1 pound gets me 650. 1.5 pounds gets me 740. 2 pounds gets me 830. 2.5 pounds gets me 920. So I do see that I can make a line through it, but it's not starting. It lines up. It's just not starting at the origin. Okay. The graph forms a line, but does not go through the origin. Okay, so what's happening is you have a sandwich. Well, there's other things in your sandwich other than meat. There's bread and tomatoes and lettuce and maybe cheese, all kinds of those good things. And those have calories. So before you ever put the meat on your sandwich, you're already starting out with calories. So there's a start value, and that makes it not proportional. Okay, now when there's a start value, we can still see that this is still has a rate. It's just not a unit rate. So when I'm looking here, this is going up by 90, and this is going up, let's see, 650 to 40. Yeah, this is going up by 90, and this is going up also by 90, and this is going up by 90. This is extra stuff you don't really know at this point. So down here, if it was at 0, I know it's technically starting at 470. So there's a start value to my sandwich. Before I put the meat on, there's already 470 calories. And that's why this down here is kind of landing over here at 470. All right, next page. Bubba's Body Shop charges $25 an hour to fix a car. Complete the table and graph to represent the situation. Be sure to label your axis with words. Draw a straight line through your points. Okay, so we're saying that he doesn't charge you to bring the car. It's just as soon as he starts working. So there's no initial starting fee. And then it's a constant $25 an hour. So for 2 hours, I'd pay $50. If I paid $75, that'd be $3. If I paid $125, I was there for 5 hours. If I was there for 8 hours, I maybe charge $200. I see that if I'm going from time to dollars, I have to multiply by 25. So if I'm going back, I'm either dividing by 25 or multiplying by 1/25. That means the same thing. Okay, so here we have time And here we have our cost. And I'm plotting 0, 0. Ooh, if it's 0, 0, 0, might be proportional. 250, 375, 5, 125, 8, 200. Okay, I'm assuming that you can be charged for half of an hour. I don't know how his system works, but I'm assuming you can be. So when I take a line, I can put a line through this. So I have a line that goes to the origin, which means it's going to be proportional. So yes, they are proportional. Okay, I know it by two ways. From my table, I can see that time, the cost, is equal to 25 times the time times the hours. Or from my graph, I can see that it's a line through the origin. So two ways I know that it's proportional. Okay, my independent was time. My dependent was cost, dollars. Okay, and my graph, it is a line through the origin, which means it's proportional. All right, number 5. The day after Thanksgiving, Games R Us gives wristbands for unlimited play by charging an entrance fee of $5 and then $2 per hour. Complete the table and graph to represent the situation. Be sure to label your axis. Draw a line through the points if you can. So I know it's not going to be proportional because there's a starting fee. Right there. That tells me it's not proportional. At $0, I have to pay, at 0 time, I have to pay $5. And then $2 an hour. So at 1, I have to pay to get in, and then for an hour, so I'm at 7, and then 9, and then 11, and then 13, and then 15. When I graph this, I see that although it is a line, it will not go through the origin because it's starting at 0, 5, not at 0, 0. So although it lines up, it doesn't go through the origin. Okay? 7 divided by 1 is not the same as 9 divided by 2. So it's not proportional. No, they are not proportional. Lots of ways I could have told. From the context, I can straight off tell it because it has a starting fee. Okay, from the table, I can tell because I can write a proportion where it doesn't work. 9 over 2 is not the same as 7 over 1. From the graph, it doesn't go through the origin. You don't have to write all those reasons. You have to write one reason. But there's different ways you can tell. Okay, so my independent was time and my dependent was cost. And my line was not proportional because it did not go through the origin. line, not through the origin. All right, in math, we often make conjectures after observing something. For example, if you observe that your math teacher wore a geeky math shirt every day for the first week of school, you might make a conjecture that your math teacher will wear a geeky math shirt the second week of school. A conjecture is based on observations similar to an educated guess that you have to justify. So conjecture means it's not quite a rule yet. It's what you think the rule is. You just haven't tested it yet. Okay, make a conjecture about how to determine if the table of values represents a proportional relationship. You have to be able to multiply one variable by a number to get to the other variable. Whoops. Whew. If all the independent values can be multiplied by the same constant value, to get to the corresponding dependent values. Okay, what about a graph? A graph has to be a line through the origin. If the data forms a line through the origin. All right, when two quantities are proportional related, their unit rate is the same throughout the table or constant. The rate is also called the constant proportionality or the proportional constant. Wow, lots of different names, right? We have unit rates, also known as the constants, or the constant proportionality, or the proportional constant. So anytime we see that, it means the same thing. The unit rate's going to be more labeled, though. Okay. Peter would like to rent Wave Runners for his birthday party he's planning. He's turning 16. Crazy Rentals was found to be the least expensive, but they only have 8 left to rent the day he was looking to have the party. Each Wave Runner holds 3 people. Okay, so I know if I don't have a Wave Runner, I can't put any people on it. I'm not trying to drown my party people. If I have one Wave Runner, I can put 3 people on it. So I know when it says each Wave Runner holds 3 people, to get from number of Wave Runners to riders, I have to multiply by 3, which means if I'm going the other way, I have to divide by 3. So 6 divided by 3 is 2. 3 times 3 is 9. 15 divided by 3 is 5. 24 divided by 3 is 8. We're going to graph this. We have the number of runners, the number of Wave Runners, and the dependent is the number of riders. And on this one, we probably could actually, because it told us how to do it, but if it didn't tell us how to do it, we could probably reverse it. That's when you can kind of argue both ways. All right, so plotting it. 0, 0, 1, 3, 2, 6, 3, 9, 5, 15, we have to plot them all enough that we can see, hey, they're going to form a line. So I am grabbing my line. And I say, yep, it's forming a line through the origin. Find the ratio of number of Wave Runners for several distant points. Okay, so let's do it. We have to put the riders on top. Riders to runners. So riders. That's sloppy. Riders to runners. So if we look, 3 over 1 is the same as 6 over 2 is the same as 9 over 3 is the same as 15 over 5 is the same as 24 over, that's a 4, 24 over 8. So right here, our reduced one is where we see the unit rate. So when the independent value is 1. Okay, 0, 0. And this problem means if there's 0 runners, we can't help any riders. If there are no wave runners, then the guests cannot be riders. Okay, so we see that when we are at the number of wave runners, we multiply by 3 to get the riders. So here it says our riders is R and our number of wave runners is 3. So R is equal to 3 times N. We built an equation. Okay, so are they proportional? In the table, yes, the number of wave runners is always 3 times the number of riders. I stuttered. The number of riders is equal to three times the number of runners. In the graph, we know it's proportional because it's a line through the origin. By the end of module 5, you're going to be so tired of hearing line through the origin. On the equation, there is only multiplication. There is no addition or subtraction. So since it doesn't have addition or subtraction, there's no starting fee. Okay, it's in the format of dependent variable is equal to some number times the independent variable. State the constant proportionality. What's the number we're multiplying all the time by? We're multiplying by 3. So the constant of proportionality in this problem is 3. It's the number we multiply between the variables. State the independent and dependent. All right, we did that because we already graphed it. So our independent was runners, and the dependent was riders. Use the relationship and graph to determine how many wave runners Peter needs to rent if there was 21 people at his party. Okay, so if I throw down a 21 over here, I know I have to divide to get back. He needs to rent 7. Or I cannot look for 21, 21 over here on my graph. 21, 21, 21, it's right there. I look down and it correlates to 7. So I can see it on my graph or I can see it on my table. He would have to rent 7 runners. What is the relationship between the number of riders and the number of wave runners? Riders, the dependent variable, is equal to 3, our constant proportionality, times the runners, our independent variable. All right, here we go. Identify the following graphs are proportional and justify our reasoning. So I look, it's a line, that gets me excited, but it does not go through the origin. So is it proportional? No. It does not go through the origin. Okay, this one, it is a line through the origin. So yes, line through the origin. Now this one is not the best way to state the constant proportionality, but I look at when we have a 1 and I have to figure out where my line goes. So I'm looking here at the value 1 and I want to know when it hits the line. Well, it's hard to say because this line needs to be extended. So I'm going to go ahead and try to extend this line. Whoops. Let me redo that. I got off of it. Extend this line. And if I extended this graph line, so it looks about, that would be 5, that would be about 6. So 6. Okay. Is this one proportional? No, it's not a line. And this one proportional? No, it's not a line. All right, next page. For the 2 scenarios below, complete the table and determine if it shows a proportional relationship. A flower that is 3 inches tall when it is planted grows a ½ inch every 4 weeks. Okay, so at 4 weeks, it's going to be 3½ inches. Well, another 4 weeks have passed, so now we're at 4 inches. Now another 4 inches have passed, so we're at 4.5. Another 4 inches have passed, so it's at 5. Is it proportional? No, because it does not start at a height of 0. No, the data does not go through 0, 0. It has a starting height. Okay, the sum of 2 numbers is 0. Okay, well, -2 plus 2 is 0. -1 plus 1, 0 plus 0, 1 plus -1, 2 plus -2, 3 plus -3. Okay, it's going through 0, 0. That's good. So now I have to determine, is there a number I can multiply the x by to get to the y? And I see, yeah, every time I can multiply by -1. So is it proportional? Yes. it is proportional. And the proportional constant is -1. All right, now we're just looking at situations. We have to think, is it proportional or not? And if it is, we have to say it's independent or dependent. Carlos wants to buy some video games. He buys, what? Each game he buys costs him $36. Is the relationship between the number of games Carlos buys and total price proportional? Well, I have to think. If he bought 0 games, is he paying $0? Yes. And then it's $36 per game. So yes, it is proportional. So is the relationship proportional? Yes. Okay, if it is, we have to say what the independent and dependent values are. So independent is number of games. And dependent is the cost. Or dollars. Okay, a single concert ticket costs $56, while buying 5 tickets costs $250. Is it proportional? All right, let's look if they reduce. $56 for 1 ticket. And we have to figure out $250 for 5 tickets. Whoops, 5 tickets. Ticket. 5 tickets. Okay, so the first one's already reduced. You can't reduce that more. The second one, if I reduce that, I get that 1 ticket would be $50. So no, it's not proportional because we get a better deal when we buy more. No. Okay. These do not reduce to the same value. So over here, 56 over 1 is not equal to 250 over 5. Anna's having a new video game. It takes her 5 hours of playing the game to master level 1. After so much time, Anna understands the game better. It only takes 3 hours of playing the game to master level 2. Is the number of hours played in the game proportional? No, she's getting faster as she gets to the levels. So not proportional. Her solving rate increases. All right, that's the lesson. If you're doing electronic, hit save. If you are on paper, neatly put it in your binder, and then you are off to do your homework. Have a good day.